Hey there, what's up guys? In this video, I'd like to take you through a past paper question on analytical geometry. So first, let's study the sketch. We have a rectangle ABCD. The coordinates of A and C are given, but B and D is unknown. If you have a look at the line AD, the equation is given there as y equal to 2x plus 16. We see the diagonals AC and BD intersect at M. So M is the midpoint of AC and BD. As we already know, the diagonals of a rectangle bisect one another. Then the angle of inclination of BC is alpha. Okay, let's answer the first question. Question 3.1. Calculate the coordinates of M. So, since M is the midpoint of AC, we can use the coordinates of A and C to calculate M. First, I add the x's, -7 plus 6, divide them by 2, and add the y's, 2 plus 3, divide that by 2, and the coordinates for M therefore is -1 over 2 and 5 over 2. Okay, moving on to question 3.2. Write down the gradient of BC in terms of P. So our answer will be in terms of P. To do this, we're going to use the coordinates of C and F. Since B, C, F are all collinear, I can find the gradient for FC and know that will be equal to the gradient of BC because it's the same line. So using the coordinates of F and C, the gradient of BC is going to be 0 minus 3 over P minus 6. And that leaves us with -3 over P minus 6. And that's our gradient in terms of P. So, on to the next question. Hence, calculate the value of P. So we're going to be using the answer of our previous question. Now, since we know that line BC is parallel to line AD, the gradient of AD is given to us at 2. It's in the equation y equal to 2x plus 16. So it's given as 2. So therefore BC's gradient will also be 2 since AD is parallel to BC because opposite sides of a rectangle are parallel. Now let's substitute that gradient for 2. So 2 is equal to -3 over P minus 6. If we cross multiply, we get 2P minus 12 equal to -3. Taking the -12 over, you get -3 plus 12, which is equal to 9. And so 2p is equal to 9, which makes p equal to 9 over 2, or 4,5. Now, for question 3.4, calculate the length of DB. We don't have the coordinates of D and B, but if I work out the length of AC, it will be equal to the length of DB because the diagonals of a rectangle are equal to one another. So therefore DB will be equal to AC. So I'm going to use the coordinates of A and C to work out the length of DB. Now let's substitute into the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. Now substitute the coordinates of A and C. That gives us the square root of 6 minus -7 squared plus 3 minus 2 squared, and this is equal to the square root of 169 plus 1, which is equal to the square root of 170. And that's the length of DB. You could write this in its decimal form. That will give us 13.04.